Alright guys, we had just left off on finding the domain of the two functions we were provided. And so the last operation that we have to do from these problems is the function composition of the two fractional exponent functions. So the first operation that we encounter asks us to identify f of g of x. So what that means is we're going to take the operation g of x, this piece here, and plug it in anywhere we see an x in f of x. So this is also the same thing as saying f of 81x to the 1/2 power. So that's going to be 9 times 81x to the 1/2 raised to the 1/3 if I just completely replace the x that's there. So then what I can do is I can distribute that 1/3 power. So I'll have 9 times 81 to the 1/3. And then when I distribute this 1/3 to this 1/2, that's going to become x to the 1/6 power because those are going to multiply together. From there, I just want to see how I can further simplify the operation that I'm given. So this is 9 times the cubic root of 81. And that's times, I can either leave this as x to the 1/6 or I could make it the 6th root. It doesn't really matter. Now this example specifically gives us a little bit of practice simplifying roots. So we can call this 9 times the cubic root of 27 times 3 times x to the 1/6. And then what I can do is I can simplify this cubic root of 27, which is 3. And when I bring that out and multiply by the 9 here, I'm going to get a 27. So I'll have 27 times the cubic root of 3. That one's stuck inside of the cubic root. And then I've got an x to the 1/6 out here. So this expression is about as simple as it's going to get. So that would be my final f of g of x. Then what I can do is I can check out the next option down, f of g of 64. With this operation, what it asks us to do is to take 64 and plug it in for the x value that we found here in our previous operation. So that's going to be 27 times the cubic root of 3 times 64 to the 1/6. Now 64 to the 1/6 is the same thing as the 6th root of 64. It's something you can evaluate on your calculator. It's just going to give you 2. So you'll end up with 27 times the cubic root of 3 times 2. Or if I multiply that 27 and that 2 together, that's going to be a 54. And then the cubic root of 3 is still stuck in there. There's nothing else we can do at that point. So that's one of the directions of the function composition. So unfortunately, that one doesn't look quite as nice or doesn't cancel out as well as some of the things do with polynomial functions. But it's definitely still something that we can evaluate. And then after this, the last thing to do is to reverse the function composition. So before we had f of g of x, now we want to try out g of f of x. So if I go back to my functions, little ways up here, this time when I do g of f of x, what I'm going to do is take my f of x, this whole entire thing, and I'm going to plug it in to this x value right here. So I can write this as g of 9x to the 1/2 power, which is also equal to 81 times 9x to the 1/2 power, all raised to the, 9x to the 1/3 power, all raised to the 1/2. So just like before, I need to do some distribution of that exponent. So that's going to give me 81 times 9 to the 1/2 power times x to the 1/6 power. If I multiply those exponents together again. Now this one is a little bit nicer in that when I do 81 times 9 to the 1/2, that's the same thing as 81 times the square root of 9. And the square root of 9 is just 3. So I'll end up with 81 times 3, which is going to give me 243. So I'll have 243 times the 6th root of x, or x to the 1/6. Either one of these would be equivalent. So that's our final answer there. Last one is just to plug 8 into that operation. So we'll have 243 times the 6th root of x, or x to the 1/6, is what we're working with, and we're going to plug 8 in there. So we'll have 248 times the 6th root of 8. And there's nothing else we can do to simplify beyond that point because 8 isn't going to be a perfect 6th root. So unless we were getting a decimal approximation, we'd be all done there. So I apologize if that's not a super pretty example. We didn't have any really nice whole numbered operations there in that function composition, but those are the steps we're going to take to evaluate one function at another function.